I want to make more videos on the conceptual side like this. So today we're answering the question I think confuses people in pretty much all levels of math, like in IM1, for example, when we're talking about point slope form. If we're shifting a graph over so that it hits whatever our x value is, x1, we are subtracting from the x. Even if we're shifting it right, we subtract from the x. If we are shifting a parabola over so that its vertex is at x equals h, we subtract from the x. If it's a circle, to move the circle's center from 0, 0 to hk, we subtract x from, or h from x. We subtract k from y. That seems like the opposite of what you should do. So let's actually figure out what's going on here. Let's say I have y equals x squared. Here's a bunch of points on y equals x squared. Don't panic if you're not familiar with y equals x squared. I'm just using it as some random example graph. And then here's y equals x minus 2 squared. Somehow, by subtracting 2, we've actually gone this way. Well, let's think about what happens if, for example, I plug in 2. If I plug in 2 here, I just get 2 squared, right? But if I plug in 2 here, I get 2 minus 2, which is 0 squared. Plug in 3 here, I just square 3 and I get 9. Plug in 3 here, subtract 2 first, get 1. Then square, get 1, because 1 squared is 1. Now, obviously, you can see how the numbers work. You can plug all of these x values in and see that these are the numbers you get. But how do we bridge the gap between plug in, that's what you get, and this makes sense conceptually? If we're just thinking about the function x squared, if we're just thinking about this in terms of, well, it's still x squared, I just moved it. The 3 is getting treated as 2 less than it really is, right? The 2 is getting treated as 2 less than it really is, so it's getting treated as 0. We have essentially taken our input and made it 2 less always. Every x I could plug in is 2 less when it gets squared than it was when it was over here. So if I want to get the same y value that I got before, let's say 0, 0, for example, where does 0, 0 end up when I transform x to x minus 2? Well, if I want to get the same y value, if I still want to get 0, I can no longer plug in 0, I have to plug in 2. I have to plug in 2 greater than I plugged in before, right? Because that's going to counteract this minus 2. When I plug in 3 here, I get 9. If I want to get the same thing over here, I'm going to need to still end up plugging 3 into the square, which means I actually have to plug in 5, because that's 3 plus 2, so that when I subtract 2, I get back to 3. Then 3 squared, and you get 9, right? So you end up at 5, 9, whereas here you're at 3, 9. That's the idea. Of course, there's nothing special about x squared or the number 2, right? I can make up some random function y equals f of x, and the same idea still applies. If I graph now y equals x minus h, whatever I got at 0 before, if I want to get that same thing, I need to plug in h, so that I actually end up getting f of 0. If I want to get what I got previously at 1, I'm going to need to plug in h plus 1, so that I end up getting f of 1. If you want to get the same number, whatever you did to x, or whatever you did to y for that matter, you'll see how this generalizes. Whatever you do to x for now, you're going to have to undo in order to get the same number. Same goes for y. Right? Nothing special about x. If I take y equals f of x and instead I graph y minus 3 equals f of x, in order to get the same x value that I got before, y has to be 3 greater. So at the same x, we need 3 greater, which means an upward shift of y in order to counteract that minus 3 that I put on the y. Similarly, scaling a function, right, going from y equals f of x to y equals f of x over 2, if I want to get the same thing that I got before, then I need to plug in 2x, whatever my x was, right? I need to plug in 2x to get the same y as before. So everything that happened at some x value is now actually happening at twice that x value to counteract that dividing by 2. And then you can mix and match these subtractions and these divisions to actually move to the right and stretch to get actually what you have here, just rearranged, right? Notice, take my point slope form, rearrange it by subtracting y1 and dividing by m, and I get something that looks very much like the examples we just looked at. Take my vertex form, subtract k, divide by a. I get something that looks very much like the examples we just looked at. It's just y equals x squared, but I move h over by subtracting h from the x. I move k up by subtracting k from the y. And then I scale the y up by a factor of a by dividing by a. It's all this. That's the idea. Hopefully that was helpful. I gotta go to class. Bye.